On June the 11th, 2026, the United States Climate Prediction Center did something it does not do lightly. It took the official alert level for the Pacific Ocean and moved it up a notch, from El Niño Watch to El Niño Advisory. The reason was sitting right there in the data. The Niño 3. 4 region, the patch of equatorial Pacific Ocean that scientists use as the master thermometer for the entire planet's weather engine, was running about 0.7 degrees Celsius above its long-term average and rising. Just 5 months earlier, in January of 2026, that same stretch of ocean was doing the opposite. It was cool. A weak La Niña was in place, with the water running 0.6 degrees below average. In under half a year, the Pacific flipped from cold to warm, passed straight through neutral, and kept climbing. That is not a subtle shift. That is a full personality change in the largest ocean on Earth, and it happened fast enough that forecasters have been revising their numbers upward almost every single month since. Here's where it gets more serious. As of the most recent diagnostic discussion, the Climate Prediction Center puts the odds of El Niño persisting all the way through the winter of 2026 into 2027 at somewhere between 96 and 98%. That is about as close to certain as a seasonal forecast ever gets. But the number that should really get your attention is this one. Independent estimates now put the probability of this event becoming a so-called super El Niño, one of the rare, high-magnitude events that reshapes weather on every continent, at around 63%, with a likely peak somewhere between November of 2026 and January of 2027. Some ensemble models are now showing sea surface temperature anomalies in the equatorial Pacific, reaching 3 to 4 degrees Celsius above average by the time this thing tops out. If that verifies, we are talking about an event that sits among the strongest ever measured with modern instruments, in the same company as 1997 and 1998, and 2015 and 2016. The two events that, until recently, defined what a monster El Niño even looks like. So let's back up and talk about what is actually happening beneath the surface of the ocean. Because the mechanics here are not mysterious, they are just enormous. Under normal conditions, trade winds blow steadily from east to west across the tropical Pacific, along the equator, from the coast of South America toward Asia and Australia. Those winds drag warm surface water with them, piling it up in the western Pacific, near Indonesia and the Philippines, where sea levels actually run measurably higher than they do near Peru and Ecuador. As that warm water gets pushed away from the South American coast, cold, nutrient-rich water rises up from the depths to replace it, a process oceanographers call upwelling. That cold water feeds enormous fisheries off the coast of Peru, which is actually where this entire phenomenon got its name, because Peruvian fishermen centuries ago noticed the warm water sometimes showing up around Christmas, disrupting their catch, and they started calling it El Niño after the Christ child. During an El Niño event, that whole system breaks down, the trade winds weaken, and in the more extreme cases, they can even reverse direction. Without the wind holding it in place, the warm water that would normally be stacked up near Asia starts sloshing back eastward across the entire width of the Pacific toward South America. Beneath the surface, this arrives as something called a Kelvin wave, a slow-moving pulse of warm water that can take weeks to cross the ocean basin. Scientists monitoring the TAO Triton buoy array, a network of sensors anchored across the tropical Pacific, have been tracking exactly this kind of warm subsurface pulse advancing eastward through the spring and summer of 2026. It's essentially a preview, playing out weeks or months before the surface temperatures themselves catch up. Once that warm water reaches the surface near South America, the ocean starts pumping enormous quantities of heat and moisture into the atmosphere above it, and that is when the whole planet's weather starts to notice. Now, not every El Niño is created equal, and this is a distinction that matters enormously for what comes next. Scientists classify these events using something called the Oceanic Niño Index, which tracks the 3-month running average of that sea surface temperature anomaly in the Niño 3. 4 region. An anomaly above 0.5 degrees Celsius counts as El Niño, full stop. Above 1.5 degrees, it graduates to a strong event. Above 2 full degrees Celsius, you are in rare territory, and informally, meteorologists and climate scientists start using the term super El Niño. Since global record keeping in this form began around 1950, there have only been 6 events that reached that super threshold. In the last 25 years alone, there have been exactly 2, one in 2015 and 2016, and one in 2023 and 2024. Before that, you have to go back to 1997 and 1998, and before that, 1982 and 1983. These are generational events. They do not happen every year. They do not even happen every decade reliably. And when they do happen, they tend to leave a mark on the historical record that lasts. Which brings us to the uncomfortable comparison that several climate scientists have started raising out loud in 2026. Some of the longer-range forecasts for this event are drawing comparisons not to 2015, not even to 1997, but to 1876 through 1878. which stands as the strongest El Nino ever reconstructed from historical and paleoclimate records. That 19th century event triggered what became known across parts of Asia as some of the most severe drought conditions in 800 years, according to researchers who have studied the monsoon failure that accompanied it. The associated famines, spread across regions of India, China, Brazil, and parts of Africa, are estimated to have contributed to the deaths of tens of millions of people, with some historical estimates running as high as 50 million. Nobody is forecasting a repeat of the human toll from a 19th century famine because the world today has irrigation, food storage, early warning systems, and disaster response infrastructure that simply did not exist 150 years ago. But the fact that credible forecasters are even reaching for that comparison rather than reaching for 2015 or 1997 tells you something about how seriously the current trajectory is being taken inside the climate science community. There is one more factor layered on top of all of this, and it is arguably the most important piece of context in the entire story. This El Nino is not developing in a vacuum. It is developing on top of a planet that has already warmed by roughly 1.4 degrees Celsius above pre-industrial levels, almost entirely because of the accumulation of greenhouse gases from burning fossil fuels. Every previous super El Nino in the modern record occurred against a cooler baseline than the one we are sitting on right now. That matters, because El Nino does not just move heat around. It briefly releases a huge amount of heat that has been stored in the deep ocean up into the atmosphere. And when you add that seasonal pulse of heat to a baseline that is already elevated by human-caused warming, you get temperature extremes that go beyond anything either factor would produce on its own. This is part of why climate scientists are already treating the arrival of a strong 2026 El Nino as close to a guarantee that global average surface temperature records, the one set during the last super El Nino in 2023 and 2024, will be broken again, likely in 2027 once the full atmospheric effect of the ocean heat release plays out. Let's talk about timing, because this is where the forecast gets specific enough to actually matter for planning purposes. The World Meteorological Organization has said that the most rapid phase of strengthening is expected to occur through July, August, and September of 2026, essentially right now and through the rest of this summer. By the September through November window, the probability of El Nino conditions being firmly in place is running close to or above 90% across nearly all of the major forecasting centers, whether that's the American Climate Prediction Center, the European Center for Medium-Range Weather Forecasts, or Australia's Bureau of Meteorology. From there, models from NOAA and from the Geophysical Fluid Dynamics Laboratory both point toward a peak somewhere in the window of November 2026 through January 2027, after which the event is expected to begin a gradual weakening through the remainder of that winter and into the following spring. That puts the most intense phase of this event squarely over the Northern Hemisphere's winter holiday season and the first weeks of the new year, which historically is exactly when El Nino's fingerprints show up most clearly across weather patterns in North America, and it lines up with a roughly 97% probability that forecasters are giving for El Nino conditions persisting all the way into early spring of 2027. So what does all of this actually mean on the ground, region by region? Let's start with North America, because that is where the most detailed modeling exists right now. A strong to super El Nino tends to push the Pacific jet stream into a more extended, more southerly track, stretching from the eastern Pacific across the southern tier of the United States. That pattern typically means a wetter than average winter across the southern United States, from California through Texas and along the Gulf Coast, with an elevated risk of flooding in areas that are already prone to it. At the same time, the northern tier of the country, from the Pacific Northwest through the upper Midwest and into the Northeast, tends to run warmer and drier than usual, with reduced snowpack in mountain regions that depend on winter accumulation for their water supply the rest of the year. Meteorologists tracking the amplified winter pattern emerging in long-range models for the United States and Canada have also flagged the potential for disruptions to the polar vortex, the band of cold air that normally stays locked up near the Arctic, which, if it wobbles or splits, can send unusually cold air plunging southward into parts of North America and Europe, even in a winter that is warm on average. That's part of what makes El Nino winters so tricky to summarize in a single sentence, because the same event can produce a warm, dry pattern across most of a continent while still setting up the conditions for a sharp, short-lived cold outbreak somewhere else. Moving south, Central America and the Caribbean are among the regions forecasters are most concerned about for drought this year. El Nino reliably suppresses rainfall across a wide swath of the tropics north of the equator, and that includes Mexico, Central America, and many of the Caribbean islands, where water security is already a fragile issue in a normal year. Northern South America tends to see a similar drying effect, while further south, in parts of Peru and Ecuador, the warm ocean water sitting directly off the coast can bring torrential rainfall and flooding to areas that are normally arid echoing what happened during the extreme 1997 and 1998 event, when coastal Peru experienced catastrophic flooding even as other parts of the world dried out. Across the Pacific and Southeast Asia, Indonesia, and Australia, the pattern tends to run in the opposite direction. El Niño typically means reduced monsoon rainfall and hotter, drier conditions, which raises the risk of both agricultural drought and wildfire. Researchers at the World Resources Institute have specifically flagged elevated fire risk for Southeast Asia and Australia later in 2026 and into 2027, alongside a similar risk in Canada, where El Niño years have historically brought hotter, drier summers and thinner winter snowpack, conditions that were directly implicated in Canada's record-breaking 2023 wildfire season. It's worth being precise here, because it would be easy to overstate the direct causal link. El Niño creates hotter, drier background conditions that make fires easier to start and harder to control, but the actual ignition sources in most of these fires are human activity, whether that's logging roads, agricultural clearing, or accidental ignition layered on top of a landscape that El Niño has primed to burn. India and South Asia face their own version of this risk, because the South Asian monsoon, the seasonal rainfall system that a huge share of the region's agriculture depends on, tends to weaken during El Niño years. A weaker monsoon means less water for rice paddies and other staple crops across a region that is home to well over 1 billion people who depend directly or indirectly on that rainfall arriving roughly on schedule. East Africa tends to see the opposite problem, with El Niño historically associated with increased rainfall and flooding risk in countries like Kenya, Somalia, and Ethiopia, sometimes following closely on the heels of drought years, which creates a genuinely difficult whiplash for agricultural systems and infrastructure that are built for one extreme or the other, not for rapid swings between both. It's worth pausing here to underline just how broad the fingerprint of a single ocean basin can be. We are talking about one patch of the Pacific Ocean, roughly the size of the continental United States, running a few degrees warmer than normal. And that single change is enough to simultaneously dry out Indonesia, flood coastal Peru, weaken the Indian monsoon, dampen hurricane activity in the Atlantic while amplifying it in the Pacific, and shift the jet stream enough to change where snow falls across North America for an entire winter. That is the scale we are dealing with. And it's why El Niño, more than almost any other single climate phenomenon, gets described by scientists as a genuine driver of the planet's year-to-year weather, not just a regional curiosity. Now let's talk about the parts of this story that tend to get less airtime than the weather maps, starting with food and agriculture. Researchers who study the historical relationship between El Niño and global food systems have documented consistent links between strong events and reduced yields for major staple crops, particularly in regions dependent on monsoon rainfall, or already operating close to the margins of water availability. Coffee and cocoa markets, both of which are extremely sensitive to rainfall timing in production regions across Southeast Asia, West Africa, and South America, have historically seen price volatility spike during strong El Niño years, and early 2026 commodity markets have already been pricing in some of that risk. Fisheries face a related but distinct threat. The same warm water that disrupts weather patterns also disrupts the cold, nutrient-rich upwelling that anchors some of the most productive fishing grounds on the planet, particularly off the coast of Peru and Ecuador, where anchovy fisheries, among the largest in the world by volume, have historically collapsed or sharply declined during major El Niño events, with direct consequences for the livelihoods of coastal fishing communities and for global supplies, a fish meal used in agriculture and aquaculture worldwide. There is also a documented, if less widely discussed, relationship between El Niño and civil conflict. Researchers studying the connection between climate variability and organized violence have found that the risk of civil conflict onset roughly doubles in El Niño years compared to La Niña years, particularly in tropical countries where agriculture makes up a large share of the economy and where a failed harvest can translate quickly into economic desperation and instability. The mechanism isn't mysterious. When El Niño triggers drought or flooding that destroys a harvest or a fishery collapses, the economic shock that follows can strain already fragile institutions, displace populations, and heighten competition over increasingly scarce resources like water and arable land. None of this is deterministic. Plenty of El Niño years pass without triggering conflict in any given country. But the statistical relationship across decades of data is strong enough that researchers and policy institutions treat it as a genuine risk factor worth monitoring, not just an academic curiosity. Public health systems also see measurable effects. Warmer, wetter conditions in some regions expand the range and season for mosquito-borne diseases like dengue, malaria, and Zika, while drought conditions in other regions strain access to clean water and sanitation, which drives up rates of waterborne illness. Extreme heat itself is a direct health threat, and El Niño years have historically coincided with spikes in heat-related illness and mortality. particularly in regions that already sit close to the upper limits of human heat tolerance during the warmest months of the year. So, given all of that, how confident should we actually be in these forecasts, and how much of this is still genuinely uncertain? This is important because seasonal forecasting, even with the sophistication of modern climate models, is not the same as predicting tomorrow's weather. One phrase that shows up again and again in the forecast discussions from early 2026 is the spring predictability barrier, a well-documented tendency for ENSO forecasts made in the Northern Hemisphere spring to be significantly less reliable than forecasts made later in the year. That's part of why the confidence intervals on this event tightened up considerably as 2026 progressed. Back in January, forecasters were still hedging heavily toward ENSO neutral conditions for the months ahead, with El Niño sitting as a distant third possibility behind lingering La Niña and neutral conditions. By May, the picture had flipped, with El Niño probabilities for the June through August window jumping to around 80%. And by June, NOAA had moved from forecasting language to declarative language, saying plainly that El Niño conditions were no longer something being forecast. They were present, observed, confirmed in the data. That evolution, from hedged uncertainty in January to near certainty by June, is itself part of the story. And it reflects genuine strengthening in the underlying ocean signal, not just forecasters growing more confident in a static situation. Where the real uncertainty remains is in the final magnitude. Will this event actually cross the 2 degrees Celsius threshold that defines a true super El Niño, or will it plateau somewhere in strong but sub-super territory, more comparable to 2009 and 2010 than to 2015 and 2016? The current spread across ensemble models is fairly wide. Some runs show peak anomalies in the range of 1.5 to 2 degrees, which would still make this one of the more significant events of the past several decades without necessarily breaking into record territory. Other runs, particularly the ones that have been trending warmer with each successive update through the summer of 2026, show peak anomalies reaching 3 to 4 degrees Celsius, which would place this event at or near the top of the modern record, potentially rivaling or exceeding 1997 and 2015. The trend across recent forecast updates has consistently been upward, with each new model run showing a slightly stronger event than the one before it, which is one reason forecasters and journalists covering this story have grown more urgent in their language as 2026 has progressed. But it's worth being honest that nobody, no model, no institution, can tell you today with certainty exactly where this event will top out. What we can say with high confidence is the direction, strengthening, and the approximate timing, a peak somewhere in the November 2026 to January 2027 window, and a very high probability, north of 95% by most measures, that the event persists deep into that winter before beginning to fade. It's also worth putting some historical texture on what Super El Niño actually felt like the last 2 times it happened, because abstract temperature anomalies don't always land the way lived experience does. During the 2015 to 2016 event, California experienced one of its wettest winters in decades after years of severe drought, while at the same time, parts of Indonesia and Southeast Asia suffered widespread wildfires and haze that blanketed cities for weeks. Global average temperatures set a new record that stood until the next Super El Niño arrived. During 2023 and 2024, similar patterns played out: record global heat, disrupted monsoons across South Asia, coral bleaching events across the Great Barrier Reef and other reef systems worldwide as ocean heat stress pushed past the threshold corals can tolerate, and significant swings in agricultural output across multiple continents. If the current event does reach comparable strength, the expectation among scientists is that we would see a broadly similar set of impacts, but layered on top of a planet that has warmed further still since 2024, which means the baseline these extremes are being added to is already higher than it was even 2 years ago. There's a particular concern among coral reef researchers worth mentioning here because reef systems are unusually sensitive to exactly the kind of ocean heat pulse that a super El Niño produces. Marine heat waves associated with strong El Niño events have already driven multiple global coral bleaching episodes over the past decade, and reef scientists have expressed concern that a 4th major global bleaching event, layered on reef systems that in many cases have not fully recovered from the bleaching associated with the 2023 to 2024 event, could push some reef ecosystems past a threshold from which recovery becomes far more difficult. This isn't peripheral to the weather story, it's a direct consequence of the same ocean heat that's driving the atmospheric patterns being discussed everywhere else. It just plays out underwater, on a slower and less visible timescale than a flood or a wildfire. There's an economic dimension to all of this that tends to get less attention than the weather maps, but ends up shaping how the event is actually felt by ordinary households. Insurance and reinsurance markets watch ENSO forecasts closely, because a strong El Niño reliably shifts the geography of catastrophic risk for an entire year at a time. A wetter than average winter across the southern United States means insurers bracing for elevated flood and severe storm claims in states that don't always budget for that kind of exposure. At the same time, a historically quieter Atlantic hurricane season, which is a well-documented side effect of El Niño because of the wind shear it generates over the tropical Atlantic, tends to be offset by a more active than usual eastern and central Pacific hurricane season, which threatens Mexico's Pacific coast, and in some years Hawaii. Energy markets feel it too. Hydropower generation. In parts of South America and Southeast Asia depends heavily on rainfall patterns that El Niño disrupts. And utilities in drought-prone regions sometimes have to lean more heavily on fossil fuel generation to make up the shortfall, which creates a secondary emissions effect layered on top of the primary weather disruption. Agricultural commodity traders, meanwhile, spend the months leading into an El Niño winter adjusting futures positions on everything from palm oil, which is sensitive to Indonesian rainfall, to wheat and soybeans, which respond to shifts in both South American and North American growing conditions. None of these markets move in lockstep, and El Niño is never the only variable in play. But the historical pattern is consistent enough that trading desks and central banks alike treat a confirmed strong event as a factor worth pricing in months ahead of time, not something to react to after the fact. Governments and disaster management agencies have also learned, sometimes at considerable cost, to treat early ENSO warnings as actionable intelligence rather than background noise. After the 1997 to 1998 event, which caught many national governments underprepared and is estimated to have caused tens of billions of dollars in damage worldwide, alongside a significant human toll. Several countries built out dedicated early warning systems specifically tied to ENSO forecasting. Peru, which sits directly in the path of the most intense coastal flooding during strong events, now maintains a national multi-sectoral commission that begins issuing contingency plans the moment forecasters flag an elevated probability of El Niño, well before the event itself arrives. The Philippines and Indonesia have similarly built drought contingency protocols into their agricultural ministries, tied directly to the seasonal ENSO outlooks published by NOAA and the World Meteorological Organization. Australia's Bureau of Meteorology runs one of the most closely watched independent ENSO monitoring programs precisely because the country's agricultural and bushfire management systems depend on getting as much lead time as possible before a drought-prone El Niño pattern sets in. None of these systems can prevent the underlying weather extremes from happening, but the gap between the death tolls and economic losses of the 1876 to 1878 event and the losses associated with more recent super El Niños, even accounting for the fact that today's global population and economy are vastly larger, reflects real progress in forecasting, communication, and disaster preparedness over the past century and a half. It's also worth noting how this event fits into the broader pattern climate scientists have been tracking across the past several ENSO cycles. Researchers studying the frequency and intensity of these events over the 20th and early 21st centuries have found that both extreme El Niño years and extreme La Niña years appear to be becoming more frequent as the underlying ocean and atmosphere continue to warm, even though the natural multi-year oscillation between the two phases continues on roughly the same rhythm it always has. That means the swings themselves, La Niña to neutral to El Niño and back again, are increasingly happening between more extreme endpoints than they used to, which is part of why the 2015 and 2023 super El Niños arrived less than a decade apart, compared to the roughly 15 to 20 year gaps that separated earlier events in the 20th century record. Whether the current event ultimately joins that list of extreme outliers or settles into merely strong territory, the broader trend it's riding on top of, a warmer ocean, a more energetic atmosphere, and a climate system with less of the natural buffering capacity it had a century ago, is not going anywhere once this particular event fades. That's arguably the most important takeaway buried inside all of these forecasts and probabilities. This is not simply a story about one ocean basin having an unusually warm year. It's a story about what unusually warm years increasingly look like on a planet that has already shifted the baseline underneath them. So, where does this leave us heading into the back half of 2026? The trajectory, at this point, is about as clear as seasonal forecasting gets. The Pacific has moved decisively out of the weak La Niña that was in place at the start of the year, through neutral conditions in the spring, and into a strengthening El Niño that forecasters now describe with near-certainty language rather than probabilistic hedging. The most rapid phase of intensification is happening right now, through the summer months, with the event expected to reach its peak strength sometime in the window spanning November 2026 through January 2027. Whether that peak lands in strong territory or crosses fully into super El Niño territory remains the open question, But a majority of current model guidance, along with the observed trend of each forecast update running warmer than the last, points toward a genuinely major event, one that will be remembered alongside 1997, 2015, and potentially even reaching back toward the kind of extremes last seen in the 19th century. What happens next depends on where you're standing. If you're in the southern United States, watch for a wetter, potentially flood-prone winter. If you're in the northern tier of North America, expect warmth and dryness that could strain water supplies heading into next summer. If you're in Indonesia, Australia, or parts of Southeast Asia, elevated fire risk is already on the table for the months ahead. If you're in coastal Peru or Ecuador, the risk runs toward flooding rather than drought. If you're dependent on the South Asian monsoon, or on fisheries off the Pacific coast of South America, or on coral reef ecosystems anywhere in the tropics, this is a season to be paying close attention. And on the broadest possible scale, this event is very likely to be part of the reason that 2027 ends up setting a new record for the planet's warmest year, building on top of a warming trend that was already unmistakable before this particular ocean cycle even began. The Pacific has done this before, 6 times since 1950 that we know reached true superintensity, and each time the planet has adapted, recovered, and moved forward, but not without real costs along the way, measured in crop failures, in wildfire smoke, in coral reefs pushed to their limits, and in communities from Lima to Jakarta to Nairobi having to absorb weather extremes that arrived faster and harder than their infrastructure was built for. The next official update from the Climate Prediction Center's INSO diagnostic discussion lands on the second Thursday of August 2026, and given the pattern of the last 6 months, in which nearly every successive forecast has trended toward a stronger, not weaker, event, there's good reason to expect that update to keep pushing the story in the same direction it has been heading all year. For anyone trying to make sense of what to actually watch for over the coming months, the signals worth tracking are fairly specific. Keep an eye on the monthly Niño 3. 4 anomaly readings, since a continued climb toward or past the 2 degrees Celsius mark, is what would confirm this event has crossed fully into Super El Niño territory, rather than settling as merely strong. Keep an eye on the subsurface heat content data from the Pacific Buoy Network, because that's the leading indicator that has already flagged this event's strength before the surface temperatures themselves fully caught up. And keep an eye on how each successive monthly forecast compares to the one before it, because the consistent upward revision that has defined this event since January is itself a meaningful piece of information about how the underlying ocean system is behaving. The ocean has made its move. Now the rest of the planet has to respond to it.